So good evening, everyone.
Good evening, sir.
Good evening, sir.
So in last class, we have discussed the center of mass of different structures. So
Happy
today,
Teachers Day.
thank you, everyone.
So, sir, happy Teachers Day.
Thank you, everyone.
Happy Teachers Day, sir.
So lots of thanks to everyone, and now we will start.
Yes,
Okay, some student is still joining. Should I wait for 1 2 more minute? That's why I was waiting.
Happy Teachers Day, sir.
So basically, we have started a center of mass of continuous body. We have discussed about cone. What is the center of mass of a solid cone from the vertex?
3H by 4.
3H/4.
For a hollow,
2H by
2H/3.
from the vertex, you guys are telling me,
Yes, sir.
3.
or from base, you guys are telling
Vertex.
vertex. Now, for hollow hemisphere,
R by 2 from the base.
R by 2, and for solid hemisphere,
PR by 8.
very good. Now, guys, this point, you have to keep in mind whatever the things. What is about hollow, ring? What is for ring, guys? Half ring, half ring. Guys, forgot 2r by pi. 2r by pi, guys.
Yes.
And for disk,
4R by 3 pi.
very good, 4r by 3 pi. Now, guys, today we are going to start a very important topic from which you will learn many things. And the name of the topic you will learn slowly. I'm not introducing the name first. So let me start the discussion. Uh, we have discussed one formula, guys. What is the x coordinate of center of mass? m1 x1 plus m2 x2 plus mn xn upon m1 plus m2 plus m3, no? Is it okay?
Yes, sir.
Yes, sir.
Now, what is acceleration? What is when differentiate? When differentiate, what you will get? V center of mass, no? Which is m1 v1 plus m2 v2 plus mn vn. No?
Excuse me, sir.
Yes.
Sir, is this the velocity of the center of mass or the x-coordinate of the velocity?
This is velocity of the center of mass. I'll tell you. Actually, when we will do some question, you'll understand. X coordinate or y coordinate or that. Like suppose if you had differentiated dx by dt, basically you are writing like this. But if I'm taking r, dr by dt also be in.
Yes, sir.
So I'll tell you this. That's why we are doing detailed discussion of this thing. Don't bother. Okay. So V
Okay.
of center of mass, can I write this? Yes or no? Tell me to.
Yes, sir.
Now, guys, see. If I'm just saying that this, whatever I have written, is nothing but P1. Can I say momentum? P2 up to Pn. Momentum is mass into velocity. Is it okay?
Yes.
Okay, now. This can be simply written as momentum of the system upon summation of all the masses. I can take capital M. So can I write P system is equal to capital M mass of all the system into V center of mass? Yes or no? Tell me so.
Yes.
Now, if I say that if there is no external forces acting on the system, acceleration will be zero, no? Force external zero. If I say the external force is zero, acceleration is zero, and acceleration is zero means velocity remains constant, no? Acceleration means zero means velocity remains constant, no? So can
Yes.
I say that, guys? P of the system is equal to M, capital M into V, a center of mass. This entire becomes constant. Mass constant, velocity is constant. Means P of the system becomes conserved or constant. Constant means basically conserved. Means I can say that P final is equal to P initial. Means final angular momentum must be equal to initial angular momentum. Can I say this statement? Yes or no? I have started from x coordinate of center of mass or r coordinate of center of mass, which is m1 r1 plus m2 r2 up to mn rn upon m1 plus m2 plus mn. Then we gone to the another point, differentiated got velocity, velocity differentiated got acceleration, and I said if acceleration is equal to 0, force remains constant. Or I can say that force also 0. No external force acting on the system. If no external force acting on the system, acceleration of system of center of mass is 0. Then velocity of center of mass is constant. Na? So I have written in a system of particle, if on a system of particle, no external force acting on the system, the momentum of the system remains conserved. Why momentum remains conserved? Acceleration is equal to 0. Acceleration is equal to nothing but dv by dt. V constant. If V constant, M means mass into V center of mass is conserved. That means P initial is equal to P final. Is it okay?
Yes.
This is known as conservation of linear momentum. Please note down from here. First, momentum I explained, quantity of motion possessed by body's momentum. It is denoted by P. P vector is equal to M V vector. P of the system M1 V1 plus M2 V2 upon M1 Mn. So V center of mass can be written as this divided by M1 plus M2 plus Mn. This can be written as, okay, please start noting down. Okay, noted.
Yes, sir.
Now you write this point in a system of particles. If on a system of particle no external force is acting, the momentum of system of particle remains conserved.
Can you show the previous slide one?
Okay, guys, done. Now, which type of problem we will see here one by one. So first problem I'm giving you guys. Just let me. Actually, this is a problem which is little bit eye-opening problem for all the students who having some confusion in this type of problems. Let me ask this question to you. Okay. We have two masses, 2 kg, 3 kg. This mass moving with 5 meter per second this way, 5 meter per second this way. Find velocity of center of mass and momentum of system. Okay, guys, try to this question.
Sir, root 13 meters per second.
Magnitude, I'm not asking. I'm asking just actual value.
So what value?
Actual value, like
So 5.
I know most of you having the confusion in direction, and that's why you had a mistake.
Sir,
Can you
10
tell
I
me
cap plus 15 J cap.
how much? How much? 10 I cap plus 15 J cap.
Yes, sir.
Is what you have calculated? V center of mass or momentum of center of mass?
Sir, the system, momentum of the system.
Okay, can you calculate V system of mass? V center of mass?
Yes, sir. Then
Okay.
Sir, V center of mass will be 10 I cap plus 15 J cap divided by 5, right?
Hmm.
sir, 2 I cap plus 3 J cap.
Uh, right, you can say. Okay, listen everyone. You know that V of center of mass is equal to M1 V1 plus M2 V2 upon M1 plus M2 na? So M1 is given to this I'm talking, but velocity is 5 I cap. Are you agree? This is not 5 only. If it is in this direction only, then I can write 5, 3 like this. But if it is and this, you have to mention the direction. Is it okay?
Yes.
Now plus I'm writing 3 into minus 5 J cap. Can I write like this? Yes or no? Tell me, guys.
Yes.
Divided by 2 plus 3. That will be 10 I cap minus 15 J cap upon 5. So 2 I cap minus 3 J cap. I hope you also got this answer.
No, sir. Means I did plus 3 J cap. Yes, sir. I did a mistake. Sir.
Plus or minus, what do you get?
Minus. It
Minus.
should be
Okay,
minus
guys.
I cap.
Now those students who are little smart can say, sir, momentum so I can easily calculate by this method. M1 V1 means 2 into 5 I cap, sir, and plus 3 into 5 minus J cap, sir. So, sir, my momentum is M1 V1 plus M2 V2. That means 10 I cap minus 15 J cap. But those who follow the law, I written P of system is equal to capital M into V center of mass. What is this capital M? Total mass of the system. You can say total mass of the system is 5 and this is 2 I cap. V center of mass is 2 I cap minus 3 J cap. So can I write this is 10 I cap minus 15 J cap, which is directly calculated by the things. Are you getting my point? So this I taught you just M1 V1 plus M2 V2 plus dot upon M1 plus M2 plus is equal to this is V center of mass. This entire mass is capital M. M into V center of mass is what? P1 plus P2 plus dot. This is P of system. So that is why P of system is equal to this total mass M1 plus M2 plus M3. And that is why I multiply this is M1 plus M2. Are you getting my point? Yes or no? Tell me.
Yes, sir.
Yes,
Okay,
sir.
guys. Now, another question based on same pattern. Let me ask to you all. I have taken the next question. A pulley is like this. This mass M1, this M2. They are released from rest. You have to calculate acceleration of center of mass, acceleration of center of mass of the particle. Find this pulley's hinge, acceleration of center of mass. Don't do calculation in hurry and commit mistake. Do calculation carefully and try fast.
So what do we have to find?
Acceleration of center of mass, that is written on the right side.
Okay, sir.
M1 minus M2 by M1 plus M2 whole square into G.
Very good. Very good. Do it fast, guys. Do it fast. Although I got the right answer.
Sir, M2 minus M1 by M1 plus M2 into G.
No. It will be M2 minus M1 by M1 plus M2 whole square into G. Okay. You have just calculated acceleration. You have not done M1 A1 plus M2 A2 upon M1 plus M2. Okay. हेलो हाँ मैम बोलिए मैम एक काम करिए डिसकंटिन्यू कर दीजिए ठीक
Sir, M2 minus M2 minus M1 by M1 plus M2 whole square into G.
Correct. Okay, guys, see. Suppose I have to calculate first. Let it be M1G is acting downward. Tension is upward. So I can write M1G minus T is equal to M1A. And this will be M2G. Tension minus M2G is equal to M2A. So you can add them. So from here, you can get acceleration is equal to M1 minus M2. I have taken M1 greater, you can take M2 greater, no matter. So M1 plus M2. Now this is acceleration of this mass. Let it be A1 downward, A1 upward. So acceleration of center of mass is equal to what? M1 A1 plus M2 A2 upon M1 plus M2. No? Now M1 is M1. A1 I'll write for this. A1 is, if I'm taking this direction negative, so I'll write minus M1 minus M2 upon M1 plus M2 into G plus M2 into A2. M2 into A2. A2 is the same as like this. M1 minus M2 divided by M1 plus M2 into G divided by M1 plus M2. Na? Now, if you simplify it, so this will in denominator, it will be M1 plus M2 whole square, and in numerator minus M1, M2, and the right side M1, M2 plus. See, this is
So we can
minus
take
M1 square
acceleration
and
common.
minus M2 square. What?
So we can just take acceleration common, then it becomes M1 minus M2 by M1 plus M2 into A. So
Yeah, that also you can do here. Here, if you take A common, because one is positive, one is negative, so M1 minus M2 it will become, okay. And M1 minus M2 is like that. Simply you can write like this will be better. Otherwise, it is complicated to solve. So you can say why M1 minus M2 I have written, because A I have taken positive for A1 and negative for A2 or like that? Upon M1 plus M2. So this A acceleration I can write M1 minus M2 whole square upon M1 plus M2 whole square. Is it clear, everyone? Tell me. This is acceleration
Yes,
of
sir.
center of mass. So if they will ask you acceleration of center of mass, this is the way to calculate acceleration of center of mass. Okay. Even velocity of center of mass you can calculate by the method M1 v1 plus M2 v2 upon M1 plus M2. Is it clear to everyone?
Yes.
Yes, sir.
Now guys, listen very carefully. If I ask you a simple question, let a disk, semicircular disk like this, semicircular disk. This is semicircular, guys. This is actually moving with velocity like this. So what will happen? They will be go like this. This disk is moving with velocity v like this. So you have to calculate momentum of this. Let it be ring. Let it be ring. This ring is semicircular ring. So find momentum of the ring. How you'll find momentum of the ring, guys?
Mass into VC1.
Mass into VCUM, correct. Then
Sir,
yes,
so my network was disputed. Can you repeat the question?
the ring is actually moving with a V. So we have to calculate momentum of this ring. Okay, guys, see, it is very difficult to find out this scenario if we know the center of mass of the ring, which is that if this is origin, if you are taking this as origin, so the center of mass is 2r by pi. So center of mass also moving at this instant with some velocity v, which, so can I say that P of the ring is nothing but mass m into v center of mass. But you know that v is nothing but this v can be written as omega by r. This v can be written as omega by r. So I'm writing omega into r. R is what? Which distance? I'll take this distance, guys. Effective distance, which is 2r by pi. But omega actually must be same for this center of mass and this point, this point, this point, for every point and center of mass, omega should be same. So can I write omega as v by r? So v by r into 2r by pi, guys. So this cancel this. So I can write this is nothing but 2mv by pi. So in short, I can say that key is center of mass of the E, because what you know that guys, if I just calculate its position, so 2r by pi is the position of the body. If you calculate mass moment is equal to mass multiplied by this position vector, and if I differentiate this mass moment d by dt, so actually you can take m2 by pi r dr by dt. Dr by dt is nothing but v. So that is the thing which you have done directly here. So are you getting my point? So this type of a structure, if you know center of mass, it is very easy to calculate the momentum of the ring or like that. But otherwise, it will be what you will do. You will take a distance r. You will take here a distance at a distance at theta. You have taken an angle d theta. Then you integrate. You will get this result only. Are you getting my point? But knowing center of mass makes your problem easier. Is it clear to everyone?
Yes, sir.
Yes.
So momentum conservation actually can make your problem simpler, as well as the things you have to keep in mind. You will use these things very clearly to understand the facts. Now, I'll give you one simple problem based on this momentum conservation only. Just listen very carefully. This is a plank of mass capital M, and a boy standing here at this end of the plank is moving, started moving. This is not moving, this started moving and reaches to the other end of the plank. This boy reaches to the other end of the plank. So you have to calculate how much plank will move when boy started moving towards right. Boy starts moving and reaches to another end of the plank. Find displacement of the plank when boy reaches to the other end. Question you understood, guys? Boy started moving. You have to calculate the plank displacement when boy reaches to the plank.
Sir, is the mass of the boy given?
Mass of the boy is small m. Yes, definitely given. Otherwise, you cannot solve small m.
So mass of the boy into length of the plank divided by mass of the plank means capital M, then small m. Addition.
Okay. You are saying answer is how much? Again, repeat.
Sir, small m into L by capital M plus small m, where L is the length of the plank.
Correct, correct. So x of the plank is this much. And how much for boy? Okay, listen. When I'm asking this type of question, you have to think, suppose boy started moving towards right. What helps boy to move? When boy is moving, what force acting on the boy? Is there an external force acting on the boy? You can say, sir, boy press the ground in this direction. Ground give reaction this direction. So friction, sir, static friction actually is acting on the boy towards right. And that is why boy is moving towards right. Now listen carefully what I'm saying. Static friction helps boys to move towards right. Towards right. This is static friction acting on boy towards right only, na? And towards the plank, this is left. So when this boy will move right, the plank definitely will move left. Are you getting my point? When boy
Yes, sir.
moves right, because of friction, the plank move left because of friction only. Because you are pressing the plank downward, means in this direction, the plank will presses you like this. So you will move like this, plank will move like this. Now let us suppose if I am taking boy as a system or plank as a system, friction will be the external force acting on the system. But if I am taking boy and plank as a system, boy and plank as a system, can I say that friction becomes internal force now?
Yes,
If I'm taking whole as a system, the friction between boy and plank, which is acting equal and opposite, they become the internal force. Now, because of no external force acting on the system, I'm writing. Since boy is moving over the plank, boy is pushing the plank backward, plank is pushing the boy forward, but I'm taking both as a system. So I can say that no external force is acting. No external force is acting on boy plank system. So when no external force is acting on the system, we can conserve the momentum. Okay, one thing you have to keep in mind. Earlier, if you are taking boy as a system, when boy as a system, friction force is acting rightward. Na? So because of this friction, you cannot conserve the momentum of boy along x direction. Because of this friction, you cannot conserve the momentum of the plank along the negative x direction. But when you are taking whole as a system, we can conserve the momentum in horizontal direction because no force acting in horizontal direction. Still, we cannot conserve the momentum in vertical direction. Why, guys? In vertical direction, normal is acting on the buoyant plank both, mg is acting on both. So I cannot conserve momentum in vertical direction. I can conserve momentum only in horizontal direction. So let us take momentum in horizontal direction remains conserved. So you can say that, sir, when momentum in horizontal direction remains conserved, so I can say that, see, this plank will move towards x. This plank will move, suppose, at a distance x. Let it be. I'll take the another diagram with another color here. This question I'm doing for making everything clear. But next question I'll take the shortcut, which I'm going to tell. Suppose this boy now reaches to the plank here. This boy reaches to the plank here. And this plank from this point shifted by x. Can I say that this distance will nothing but L minus x? This distance
Yes,
with nothing but L minus x. So guys, what I can write? How much plank shifted? Can you guys tell me? So you can say that if there is no external force acting on the system, velocity remains constant. Even velocity of center of mass remains constant, as well as if center of mass initially at rest, see guys, center of mass initially at rest, finally center of mass will be at rest only. So center of mass will be at rest initially, finally center of mass will be at rest, or I can say that m1, I can write change delta x center of mass is equal to m1 delta x1 plus m2 delta x2 upon m1 plus m2 is equal to this. So what is the change in position of center of mass? Do you think so center of mass will change? If there is no external force, center of mass will not change. Position of center of mass will not change. So this will be 0 is equal to m1 delta x1 plus m2 delta x2. Can I write this m1 m2 multiplied by 0 is 0. What is the m1? Let it be mass of the plank is capital M. How much plank shifted, guys? How much plank shifted? You can take, sir, minus x. Shift in the position of the plank is this one only. This is a plank earlier. This is a plank shifted. How much boy shifted, guys? How much boy shifted? You can say, sir, boy will shift. See, very carefully, I'm telling you. This is boy earlier. This is boy earlier. Now boy reaches here. Total distance covered by the boy, if I'm saying that, he total is L, but plank itself shifted x. So can I write plus m small m L minus x? Is it okay? Check it. Because boy is moving towards, see, this is boy. Boy is moving towards right. This plank is stationary. Boy has to travel L distance. But as boy progresses, the plank also gets shifted this one. So total distance moved by boy is how much? L minus x is equal to 0. Can I say that yes or no?
yes.
Those students having confusion, just listen to me very carefully. You will understand. See, now, can I say that this is the position of boy earlier? This is the position of boy earlier, and this is the position of boy now. How much boy shifted? This much, now, which is L minus x. You can say, sir, how you can say, sir, this is only L? Because I say that this is L, I have assumed this is L. So this will be total L. Now plank shifted x here, although plank shifted x here. So this plus x, I can say that let it be y. Y plus x is equal to L. Can I say that, guys? What is y? This is y. Y plus x is equal to L. So what is y? Y is L minus x. No? So that is why I say that this boy shifted L minus x. Is it okay? Yes or no? Tell me, guys. So I can simply say that this m, capital M into x is equal to m L minus x. I'll take one side m plus m into x is equal to ml. X is equal to ml upon m plus m. This is a position of center of mass. Sorry, this is a x means Planck shifted this much. If I have taken boy, how much shifted? Boy shifted L minus x. This is x of boy. This is x of Planck. Is it clearly understood by all of you? Can I give you one more question for practice?
Yes, sir.
Okay, guys. Now, going to the next question. Question number 12. We will do 12. And if you solve 12, 13, 14, 15, all are same.
Sir, half meter.
Sir,
Okay, guys, done anyone?
sir, 2
Sir,
by
0.5
15.
meters.
How much? Point?
0.5 meters.
No, 0.5 is wrong.
Sir, 2 by 15.
2 by 15 may be correct answer. Very good. It is 0.13. Check it though.
Yes, sir.
Okay, guys. So listen very carefully. You have no class after this now?
No.
Okay, guys. Now listen carefully. I'll take this Mr. Verma, H.C. Verma himself, you know. At that time when he was writing the book, he was thin, like 50 kg only. And Mathur is friend. Okay, so let us take example. Burma is here, suppose, and Mathur is here. They are sitting at the two extreme of a 4-meter long. This is 4-meter long boat. Boat mass is given 40 kg. So its center of mass 40 g acting here. And now what they are saying that in order to discuss a problem of mechanics, okay, see, because he's a physics teacher and Mathur is also his friend. So in order to discuss the physics problem, both actually comes to the middle of the boat. Both comes to the middle of the boat. So if you are neglecting the friction with the water, how far the boat will move during the process? So can I tell you, if I'm taking whole as a system, Mr. Burma, Mr. Mathur, Verma, Mathur and boat, is there any external force acting on the system? Yes or no? Tell me.
No, sir.
If
No,
I'm
sir.
taking whole as a system, don't take only Verma as a system. Don't take Mr. Mathur as a system. Don't take boat. Take whole as a system. No external force. Can I say that? M1 delta x1 plus M2 delta x2 plus M3 delta x3 is equal to 0. Can I use this thing directly? I'm not writing now delta x center of mass is equal to this. Center of mass will not change its position. Center of mass will be same. I'm not using this. Although I will use those concepts and I got the answer. I'll tell you. But this is fine what I'm writing. So let us, okay guys, now listen very carefully what I'm saying. This is 50 kg na? And this is 60 kg na? So 50 kg will apply some friction force here to move right na? So the resultant friction you got here is of for 50 kg na? And 60 kg apply friction here to move this na? So resultant friction boat will experience here 60 kg. In which direction boat will move? Can you tell me which friction is more, guys? By 50 kg or by 60 kg?
By 60 kg.
So boat will definitely move toward the right. That I'm telling you the logic. But those students will say, sir, I have taken left. No problem. Your answer will coming negative. Are you getting my point? What I'm saying? See the friction, what the 50 kg is applying towards right. The friction which 50 kg is applying towards right is less dominating. The 60 kg is applying towards left is more dominating. But this friction will actually not doing any thing on boat. This opposite reaction acting on the boat. This boy is applying friction this way to move. This is applying this way. So this friction because of 50 kg. This friction because of 60 kg. So friction because of 60 kg is dominating. And that is why boat has to move right. But those students say, sir, I have taken boat to move left. No problem. You can take left or right. No problem. Now, guys, I'm writing here. Suppose when boat is moving toward right by x, can I write mass of boat is 40 and right x is okay, fine. Change in position of the boat x, yes or no? Now, this 50 kg has to move how much distance, guys? Can you tell me?
So 2 meters, 2 minus x.
2
2
plus
plus
x,
2
na?
plus x.
2, very good. Why 2 plus x? Because boat is
So
moving
the
right.
boat is going rightwards.
So he has to move larger distance. And tell me, 60 kg has to move how much?
So 2 minus x.
So I can say, sir, if 60 is moving toward this, better to take, this will be, sir, this will be opposite like this minus. Are you getting my point? What I'm writing? 2 minus x. Is it okay? Yes or no? Or if you want to write like this. If you want to write like this, plus 60 into 2 minus x is equal to 0. Is it okay? Tell me. I'm not checking the sign. Sign will come automatically. 40x, 50x minus 60x. How much? But this I'm writing what, guys? M1 delta x1 plus M2 delta x2 plus M3 delta x3. So what I have to take? The sign also with -1. Are you getting my point? What I'm saying? Because I'm taking right to be positive. This is position coordinate. X positive, 2 plus x positive, but 2 minus x I should take negative. So this will be 40 plus 50, 90 plus 60, 150x is equal to 150x is equal to 100 minus 120. 100 minus 120 goes right side. This x is equal to 2 by 15. If you just solve 2 by 15, the value will come 0.13. If you solve 2 by 15, check everyone, the value is coming how much? 2 by 15. You use calculator. Tell me how much value coming?
Say 0.13.
0.133 towards right. But first note down this method, guys. I'll tell you another method also. First note down this method. First note down this method. This is the simplest method to solve the question, but another method also we have. Done. Everyone noted?
Yes, sir.
Okay, now listen carefully. Another method I'm going to discuss here only. See, guys, the simplest way to think like that, but another. See, guys, when all the three will be at this position, like, can I calculate center of mass if I'm taking this as origin? Coordinate 2, 0 and 4, 0. I'm calculating center of mass. 50 into 0, this is 50, plus 40 into 2, plus 60 into 4 divided by total mass na 40, 50 plus 40 plus 60. So this is nothing but 80 plus 240. 320 divided by 115. Check it. 32 by 15. Yes or no?
Yes.
This is X center of mass when they are at extreme. But when they all come at the middle, where whole center of mass will becomes, guys? Where whole system center of mass will come? Can I say that X is equal to 2? New center of mass will come X is equal to 2. Earlier center of mass, you will check 2.133 like this. Check it. 32 by 15 is how much? 32 by 15 is how much? Check it.
Sir, 2.133.
2.133. Now listen,
Yes.
very important point what I'm saying. Earlier center of mass was 2.1333. Now center of mass comes to somewhere here. That means center of mass is shifting toward left na 2.000 because center of mass all comes in center, the whole center is center of mass. So is there any external force acting on the system?
No, sir.
So how center of mass can move this point up to 2? So in order to adjust center of mass at this point, which earlier was, how much boat has to move? This is new center of mass, X new. This is X old. So in order to keep the center of mass unchanged, how much boat has to move, guys? Tell me. Earlier,
2.
you can say that earlier center of mass, पहले बच्चों center of mass यहाँ पर था, अब center of mass मेरा 2 पर आ गया है. तो ये तो तभी होता है जब कोई एक्सटर्नल फोर्स लगता है बच्चों, तभी सिस्टम ऑफ सेंटर ऑफ मास का पोजीशन चेंज करता है ना. लेकिन मेरे सिस्टम में कोई एक्सीलरेशन नहीं लग रहा है. देयर इज नो एक्सीलरेशन एक्टिंग ऑन द सिस्टम. सो नेट वेलोसिटी रिमेंस कांस्टेंट एंड एक्सिस एंड पोजीशन ऑफ सेंटर ऑफ मास जो पहले रेस्ट में था अभी रेस्ट में रहेगा. तो सेंटर ऑफ मास एक्चुअली तुम्हारा 2.133 पे था, अब सेंटर ऑफ मास आ गया 2 पे. तो इसको रेस्ट में लाने के लिए बच्चों बोट को राइट मूव करना चाहिए. कितना मूव करना चाहिए? दोनों का डिफरेंस 2.133 by 2 minus 2, तो 0.133. Done, understood what I'm saying?
Yes, sir.
So you can do have one method, calculate center of mass earlier, calculate center of mass now, and then actually you should just check. Key earlier center of mass, it will not move, so lower has to come there. It is fine. Going to the next question. 13. You guys not fed up now? Okay, do it last question of the day. Please do it fast.
Sir, ml by m plus n.
Very good. See guys,
Yes,
this
sir.
is simple
Same.
question again. Let us this break, and actually this will move towards right. And as it is moving towards right, the cart will move towards left. So the distance between this and this, they have given horizontal distance between string and the slot. This distance is L given. Suppose guys, if this cart will move by X, how much ball has to move to go to the slot? If the cart move X, how much board has to move to go to the slot?
Sir, L minus X.
L minus X.
So I am writing cart M is going to minus X this way plus small m moves how much distance? L minus X. So can I simply write this is nothing but ML divided by M plus M so this is the coordinate of done guys, you understood what I'm saying? आप लोग को क्या करना है बच्चों की देखना है कितना शिफ्ट हो रहा है बच्चों ये अगर राइट जा रहा है तो कैब लेफ्ट जाएगा कैब लेफ्ट जाएगा तो मास m इंटू x कैब के लिए मैंने लिखा प्लस स्मॉल m इंटू L माइनस x Is it okay, guys? Can you guys try now up to 15 at homework?
Yes, sir.
Okay, I'm stopping here. Thank you, everyone.
Thank you, sir. Good night.
Thank you, sir.
Thank you, sir. That's it.